Our topic for this day is all about atoms, molecules, and ions. Okay, first we'll discuss about atoms. Atoms, the first modern idea of atoms comes from John Dalton. In 1803, John Dalton published his idea about the atoms, and he published the following. Accordingly, atoms are the smallest particles of matter. They cannot be divided into smaller particles. They also cannot be created nor destroyed. Second is all atoms of an element are identical in terms of mass, size, and properties. Atoms of one element are different from the atoms of other elements. Third, compounds are composed of atoms of more than one element which are combined in fixed ratios. And number four, atoms retain their identity during chemical reactions which involve combination, separation, and rearrangement. Let's go on to the first statement. Accordingly, atoms are the smallest particles of matter. Smallest because, accordingly, they cannot be divided into smaller particles. But we know now this is not true because an atom actually can be divided into smaller particles. So we can still divide atoms into smaller parts. And these are the electrons, protons, and the neutrons. We call these particles as the subatomic particles of an atom. So these particles differ in terms of their charge. Electrons are negative, protons are positive, and neutrons are neutral or zero charge. In terms of mass, protons approximately 1, neutrons approximately 1, and electrons have almost no mass or zero mass. And in terms of their location, as you see on this picture, on this model, these green circles are protons and these gray circles are neutrons. The protons and the neutrons are in the center of this atom. We call this center as the nucleus. So the protons are in the nucleus and the neutrons are also in the nucleus. And the electrons are around the nucleus. In your table of elements, you can see there the atomic number and the mass number. These numbers will help you identify the number of electrons, protons, and neutrons in an atom. So first, the atomic number will tell you the number of protons in an atom. On this case, we have helium, atomic number 2. Therefore, how many protons are in a helium atom? Atomic number 2, this also means there are 2 protons. So if we try to draw this one, we have 2 protons in the nucleus. So right now, the charge of this atom is positive 2 because there are 2 protons and protons are positive. And what's the charge of an atom, by the way? What's the overall charge of an atom? It's actually neutral or no charge. But as you observe here, an atom is composed of both negative charge and positively charged particles. How come that the overall charge of an atom is neutral or it has zero charge? It's not positive, it's not negative. The reason is that the number of protons is equal to the number of electrons. So in this case, we have positive 2 because 2 protons. So we also need 2 electrons to give a charge of negative 2. Positive 2 plus negative 2, if you add this one, that's equal to 0. So these opposite charges cancel each other. So equal number of opposite charges will give a neutral charge or zero charge. So the overall charge of an atom is zero charge because the number of protons is equal to the number of electrons. And next we have the mass number. The mass number or the atomic mass is equal to the mass of all the particles here. What's the mass of this atom? So we know that the atom is composed of electrons, protons, and neutrons. So we can say that the mass is equal to the mass of protons electrons and neutrons. But as we see here, electrons don't have any mass, so we can remove electrons from this equation. So we can say the mass depends on the number of protons and neutrons alone. And on this case, each proton here has a mass of 1. So we have 1 and 2. So right now, the mass is 2. But the mass here is 4. So what is missing on this picture? We need the neutrons. So the mass is equal to the number of protons and then the neutrons. So if the mass, the mass is equal to the number of protons plus neutrons. The mass is 4 and the proton is equal to 2. And we don't know the number of neutrons. We can do simple algebra. That's n is equal to transpose 2. So n is equal to 2. So the number of neutrons here is 2. So we add 2 neutrons on this atom. So we have 1 and 1. So again, the mass only depends on the nucleus because the electrons don't have any mass. So the mass is concentrated on the nucleus of an atom. So we have 4 ang mass number. We can count here 1, 2, 3, 4. On these 4, 2 are protons and 2 are neutrons. Okay, let's go on to this example. Let's identify the atomic number of this atom. Again, the atomic number is equal to the number of protons. We can count the protons here 1, 2, 3, 4. Therefore, the atomic number of this atom is 4. Next, we go to the mass. The mass is equal to the number of protons and neutrons. Again, we don't write electrons because electrons don't have any mass, so we can disregard them. Again, proton plus neutrons. Right now, we have 1, 2, 3, 4 protons, and neutrons we have 1, 2, 3, 4, 5. 4 plus 5 is equal to 9. So the mass of this one is equal to 9. Can we identify what element this atom is? We need to look on the number of protons. So atomic number 4. What element have atomic number 4? That is beryllium. So again, beryllium atomic number 4 and the mass of 9. Next is another atom. The same thing, atomic number is equal to the number of protons. Atomic number is, the number of protons here is 1, 2, 3, 4, 5 protons. Therefore, the atomic number of this atom is 5. And the next we have the mass is equal to the number of protons and neutrons. Protons 1, 2, 3, 4, 5. Neutrons 1, 2, 3, 4, 5, 6. The mass of this atom is 11. Let's identify this element. We need only to look on the atomic number, which is 5. So what element have atomic number 5? You can check your table of elements, and that element is actually boron, and the mass is 11. As a practice, you can practice answering this one. You can find out the atomic number and the mass number in the table of elements, and then you can do some addition, subtraction, and identify the number of protons, electrons, and the neutrons. So we just discussed the first updates on the atomic theory. We now know that atoms are not the smallest particles of matter and that they can be divided into smaller particles. These particles are electrons, protons, and neutrons.